This is your help video for quiz 1.06. Alright, which figure demonstrates a translation? Now remember, a translation is just a shift. We're going to move it up, down, left, right. We're just shifting it. We're not flipping it. We're not turning it. We're just shifting it. So if you take this original one, I think you can see that we're just shifting it or scooting it to the right. So this one is a translation. On this second one down here, we're reflecting it. We flipped it. So that is not a translation. For this one over here, we've actually shifted it down and we've shifted it to the right. That's still a translation though, because we're just moving it. We're not flipping it, we're not rotating it, we're not doing anything else, we're just moving it, shifting it. So that's a translation. And then for this one, we have a small figure and it gets a lot bigger. That's called a dilation. So that is not a translation. Alright, what kind of transformation is illustrated in this figure? Well, we're not just shifting it because the orientation has changed. And we're not flipping it because there's no way that we could flip it to make it end up like that. This one is a rotation. If you notice, we've rotated it this direction. So that's a rotation. And by the way, a dilation means it's getting bigger or smaller. The reflection is the flip and the translation is the slide. It's not any of those. All right, Littrell will rotate triangle ABC 180 degrees about one of the labeled points. Littrell says the image will only touch the pre-image at exactly one point. Which points could be the center of his rotation? Well, if it's only going to touch at exactly one point, the center of rotation needs to be one of the vertices. Like if we had the center of rotation at B and we rotated it however far we were going to rotate it, B would still be located right there. Same thing if you had the center of rotation at A would still be the same, or if you had it at C would still be the same, and that would be it. So in order for it to land on exactly one point, it has to be one of the vertices. Okay, which translation vector could be used? So for a translation vector, you need to pick a pair of corresponding points. So like this point of the arrow corresponds to this point of the arrow. And if you imagine taking a line and connecting those, that's going to be your translation vector, and it could go either way. It could go up or down. And you'll have the same translation vector no matter which corresponding point you pick. So let's say that you picked this point and this point. Notice that if you connect those, that gives you the same translation vector. So for the translation vector, you just connect corresponding points, and that shows you how you're translating it. So it wouldn't be any of these. It would be either this one or that one. All right, what is true about every rotation? So a rotation is a rigid transformation. So that means that it's going to save the same shape and size. It's going to preserve the shape and size. So the image and the pre-image are going to be congruent. They're going to be the exact same shape and size. The image will overlap the pre-image. That'll happen sometimes, not every time, and it wants to know what's true about every rotation. The image is larger than the pre-image. That's definitely not true. That's only true in a dilation. And then the image is smaller than the pre-image. Again, that's only true in a dilation. It's a rigid transformation, so the image and the pre-image are going to be the same shape and same size. All right, good luck, y'all.